All right. Oh, and there's another question here on 5.7 in the little figure. It says watch that band edge. Okay, so the edge, I think the lower edge of the band on the VHF for a technician is 144. You don't want to put your radio at 144 and transmit necessarily if you were doing whatever mode that is. I think it's data. You don't want to put it right there. You want to put it a little above just because you're splattering or interfering with the adjacent bands. So the question is, why should you not set your transmit frequency exactly at the edge of a band? Well, because you don't want to go over the frequency. And by the way, you're not allowed to transmit on that area, so you're actually operating illegally if you're on a bandwidth that, say positive and negative 144, and you put it at 144. So you want to go to 144.05 or something, so that when you go back down to 5, you're still within that legal area. So based on the signal strength. And then bandwidth, you can do FM narrowband or you can do FM wideband. So you might be sending a 7.5 kilohertz signal or a 15 kilohertz. 15 kilohertz would be the wideband and the 7.5 would be the narrowband. So the advantage is the narrowband, you just have less of the signal to pick up, so it might be weaker and harder to pick up on the FM. And on the wide band, it might be easier because there's more of the signal to pick up. So there's modes of that as well. Okay. Going over to 5-8, the next one. These next three questions, it says, what would cause your FM transmission audio to be distorted on voice peaks? So it's kind of like if I were just sit here and talk really loud into this microphone, it might go, it might be staticky, or your ears might hurt. So what's going to cause it to be distorted is speaking too loudly. So if you're just right here talking straight into it and you're or putting it really close, it will actually distort your signal and people have a hard time understanding you. You've probably heard that when someone gets right up and starts talking like that. Same thing. What is the effect of excessive microphone gain on SSB transmission? So SSB, single sideband, that's voice. Gain is like extra strength. So if you're talking too loud and that sort of thing, it might modulate the signal outside of the bandwidth and you might interfere. It's called splatter. And you can interfere with other channels also. So if you have your microphone gain turned up too much. The next one, they call it over deviating or splatter. They say, what should you do if you're told that your mobile transmission is over deviating? Now, I've never heard a lot of people say that, but I haven't been like super involved in listening on ham radio recently, so maybe that is something people use. But if they say you're over deviating, what you can do is talk softer, okay? Because if you're talking too loud, you end up with that interference. What is the purpose of a squelch? Okay. This one is a pretty easy one to see because there's two knobs, and one is the volume knob, and the other is the squelch knob. Okay, so most radios have like an electronic version of the squelch. It might be a number between 1 and 10. And if you set it at 0, basically the squelch is to get rid of the noise or static. So if you push MON, which is monitor, you can actually hear the static. So if you have a really faint signal, you can push MON and you can hear it. So the squelch is like getting rid of all that you don't need to hear. And in fact, let me see if I can turn this down a little bit so it's not so loud. Maybe we can hear some. You can kind of hear like some faint channels because I'm off frequency, but squelch is the turning it up is going to mean it's going to take a stronger signal before it will activate and broadcast and listen, not broadcast, trigger the speaker to play what's in the frequency. A lower squelch means you might hear more static, but you can hear weaker signals. So a squelch is really useful for picking up faint signals and useful for filtering out those faint signals when you have someone close by with a good signal that you're trying to talk to. So that's the purpose of a squelch. The next question, how can a squelch be adjusted so that a weak FM signal can be heard? So if it's really weak and really faint, you just turn down your squelch so you can hear that static, and you might hear it might be harder to hear, but you can still hear it. So you just turn down the squelch or open it up. Okay, let's see. Oh, so on figure 5.7 at the bottom, they have this big Yaesu. It's an FT840, I guess. And they have like 3 or 4 little controls, and they tell you what each of those are. One of them is called ATT, that's attenuate, which means to like weaken the signal. The other one is AF or volume gain, audio. I don't know what the F is, but anyway, it means gain. It's to increase the volume control. CLAR is clarity. Shift is to vary the receiver frequency without changing your transmission frequency. And then there's a mode button on there that will just switch between the different modes we've talked about: SSB, SW, AM, FM, that sort of thing. So you have a unit, you turn in, like this one is the frequency, the big knob is the frequency. Turn in the frequency, adjust your microphone, turn the squelch right, and then decide what kind of mode you're going to use, AM, FM, and then you start transmitting. All right, next question on 5.9. What term describes the ability of a receiver to detect the presence of a signal? So signal, it's called sensitivity. So if your receiver is really sensitive, it can, pick up signals that are maybe faint. What term describes the ability of the receiver to discriminate between multiple signals? It's selectivity. So it's like, think of it as you're in a room and there's 3 people talking at you. The radio is the same thing. It's got like 3 or 4 different frequencies, and you're going to be selective. You're a selective listener. You're going to listen to one station or the other. So that term is the ability to discriminate between different voices or different channels speaking to you at once. And then there's what's called a preamplifier. Okay, so let's say I have something like this. It's only 5 watts, but I want to transmit 25 watts or 50 or 100. Well, you can install an amplifier between here and your antenna. So I'm going to turn this off, but okay, so if I just unscrew my antenna, then I can actually screw in another antenna, an external cable, and between here and the other external cable, I would put an amplifier, so it takes my signal that's being received and sent and just amplifies it and makes it stronger. So it's called an amplifier. And where would you hook that? You would hook it between the radio and the antenna. So you put a preamp in between to boost or increase your signal, to amplify your signal. So that's the question. Where is it installed? Between the antenna and the receiver. Simple. All right. Next one. Which of the following controls could be used if the voice pitch of a single sideband signal returning your CQ call seems too high or too low? So CQ is a Morse code term for calling all stations, or hello anyone out there. It's like hello, hello anybody calling anybody. CQ is CQ. Okay, so that is CQ. So they're saying you're on a single sideband, and so you're just talking. What control can you use if it's too high? There's what's called the RIT, receiver incremental tuning, or CLAR, clarifier. That's the control that you would use. It just helps clarify the signal, kind of like enhancing it or whatever. What is the advantage of having multiple receive bandwidth choices on a multi-mode receiver? You can do strong and weak signal work. So you can do strong if it's something really close by. If you're trying to do distance, you can change it to weak. So you might use different modes based on the band and what you're trying to do. So the advantage is being able to do strong and weak signal work both. Okay, this gets in the next one is on filters. So like a party, let's say you're in a party and you had 5 people with high voices and 5 people with low voices. Maybe women talking that are higher pitched and men that are talking that are lower pitched. Well, you might put on a filter and say, I only want to hear the low pitched ones, or I only want to hear the high pitched ones. And that you do the same thing with the radio. You actually put in a filter, and nowadays a lot of those are electronic. On SSB, single sideband voice, you want to use a wide receiver, I guess, a wide filter to allow more in. So you put in filters or selecting different filters to try to discriminate and get rid of some of the noise. That's what you're using them for. What is the result of tuning an FM receiver above or below a signal's frequency? So let's say I'm trying to listen to FM 100, okay? And it's 100.0, and I tune it to FM 100.1. What's going to happen? Well, you might hear distorted audio. It might be a little garbled or something, but you might still be able to make it out. So that's the answer, distorted audio. You want to tune in right to the frequency that they're transmitting on. All right. On 5-8, oh, I already went over that. Okay. 5-9, then we'll go to 5-10. Okay. So the next one, 5-10. All right, I'm going to talk about signal strength measurement. It's kind of in the middle, 5-10. This is more for your information because I don't know that there's a test question on this, but they have what are called S meters, and it's a scale of 1 to 9 of your signal strength. So on my particular radio, it will actually show, let me just tune into a band. Let's see if I can get somebody here that's talking. There's one. Okay, well, here's somebody talking. And at the bottom, there's a little graph, and it'll go from 1 to 9. So this guy's coming in really strong, so it'll say a 9. And if it's really weak, it might be a 1 or halfway in between, like a 5. So the signal, or S meter, is a measurement of how strong your signal is coming in. There you can see the little... A double means you're talking over each other. All right, so signal strength is the S meter. They call them S1 through 9. Some people might say your signal is 20 dB over S9. 20 dB means 20 decibels stronger over the strongest signal S9. So it means you're coming in super clear, or under S9. There's also what's called AGC, automatic gain control, which allows you to increase the strength of a weak signal like Morse code or something. They have automatic ones that'll do that for you, or AM or FM signals. Squelch they refer to as when it's muted, it's closed. So if it's really turned to the right, it's high. It's like takes a strong signal to get through, and they call it tightening the squelch, I guess. Notch filter removes very narrow frequencies. Noise reduction, so that's like hearing somebody talk, but there's a lot of static in the background. Hi, how are you doing? And the noise reducer would get rid of that static. So there's a noise reduction function that some of these radios have. All right. This one's pretty basic. I actually went over this one, but what is the function of SSB/CW/FM switch on a power amp? So if you have an amplifier, there's a mode, like I mentioned, taking off the antenna and putting an amplifier between your radio and your antenna. And there's a switch on there that says SSB, FM, AM, or SSB, CW. It's what's the function of that? It's to change the mode of the signal. So you might want to amplify the SSB signal or amplify a CW, FM signal. So there's a little switch that tells you what, based on the mode you're doing, you want to switch your amplifier to that mode, amplifying that mode of signal. I haven't used an amplifier, so never used it, but apparently that's what it's for. What device increases the transmitted power from a transmitter receiver? That's an amplifier that we were just talking about. What device converts RF input and output of a transceiver to another band? Okay, that's called a transverter. I've heard it talked about, like for a repeater, they call them cross-band repeater. I might receive on VHF and I might transmit on UHF, or I might transmit on both. So I can talk to people. If this was a VHF only radio, which it's not, but let's say it is, I could hit transmit on a crossband repeater, and another friend of mine who only had UHF could still hear me and transmit back to me. So they might have, it's basically like two repeaters. One's a UHF and one's a VHF, but it's constantly receiving both signals and then retransmitting on the other band. So it's called a transverter, I guess. And so that's the answer to that question. Let's see, digital. All right. Digital modes. I haven't really done it personally myself, but I understand they're really good. I mean, I've done it with cell phones, just that's digital. Everything's digital, but I haven't done it in ham radio. But digital communication can be really good because you get rid of that noise. You also can use your bandwidth more efficiently. So you might have like 5 different people using a similar bandwidth, and because it's data, it's breaking it up and using it is what's called a multiplexer. Might be using 1/5 of the frequency for conversation 1, 2/5 for conversation 2, 3/5 for conversation 3, and so on. So you can have the same frequency that might take one bandwidth for 5 people would have to talk sequentially, whereas digital, you can all talk at the same time and use a fraction of the bandwidth because it can parse it out and send it in little packets or chunks. So what is a digital communication mode? Which of the following is a digital communication mode? That's at the bottom of 511. They have a whole list here on 512. So I'll just go through some of those. Those are different ways you can communicate digitally. So one is called, the very earliest one is RTTY, radio teletype, using a 5 baud code. So that's kind of like the early days of telegraphs where they use Morse code. It's not really digital, it's analog, but same sort of thing, only you're just transmitting data with 5 bits, excuse me. So think of an on-off switch, like 5 different switches in a row, based on the switches being up or down, it's a code, and you transmit that. That's RTTY, and I think it's been around since the 30s, something like that, 1930s. There's another one called keyboard mode called PSK31. PSK is phase shift keying. Weak signal mode, such as FT8 and WSPR, WSPR. I haven't used either of those, but those are data modes. There's a couple others mentioned I haven't used, but Pactor, Winmore, WinLink systems, AX25 protocol, B2F, JT65, that, and MSK144. JT65 is moon bounce, that's Earth, moon, Earth, that's what I was talking about earlier. That data mode, they can do that with data in addition to Morse code, and that's called JT65. And for meteor scatter, it's MSK for meteor scatter. 144, that's a data mode that they can do meteor bouncing. And then 802.11, IEEE, which is International Electrical Engineers, I think is what it's called. It's a little organization, and they set standards for wireless communication. So that's Wi-Fi. 802.11 is Wi-Fi, that's digital mode. So those are some digital modes that are used. Some of the radios, D-Star, which I mentioned, that's the Icon radios, do that. System Fusion, which is C4 FM, that's what the Yaesus use. This one uses C4 FM or digital when it communicates. DMR is another one. And then there's one called P25. This is as of 2018 in this particular manual. So those are some modes to know. There's also what's called a radio mesh network. I've never used them, but the answer is AREDN, ARADN, an amateur radio emergency data network. Is which of the following describes an amateur radio mesh network? It's AREDN, or RADN, however you say it. And they have an example on here on this corner here, and it talks about the mesh mode. So the mesh mode is basically like a bunch of units or stations communicating with each other through a network. WSJT mode, that is some kind of data mode. It says which of the following operating activities is supported by digital mode software in the WSJ suite. So the activities are Earth, Moon, Earth, and the meteor scatter. So apparently WSJT, WSJT, or whatever you say, is used for that astrophysics type of scatter of the moon or meteors. FT8 is a, says what is FT8? So FT8, just reading straight from the book, it says FT8 is capable of operating in low signal-to-noise conditions by transmitting special code sequences on 15-second intervals. So it's a data mode that if you have a lot of static in the air or harder environments to transmit, they might use FT8 because it does well with that. All right, so next question on 512 towards the bottom. Which of the following is included in packet radio transmissions? Okay, so in data, they use what are called checksums, so they'll send a bunch of ones and zeros, but before and after and during, you might have interference. So you want to know that the message I sent is the same one you received. If you remember that old game of telephone, like you whisper a message into someone's ear and you pass it on to the next person, they heard what they heard, then they transmit it to the next person, the next person. By the time you get 10 people down, the message might be slightly different or really different. And so you've got corruption of the data. So to avoid that, they might say, let's use a checksum, like how many words did I tell you? And I tell the person 5 words, the next person heard 4 words, the next person heard 3, and then you get to the end and they said, okay, I heard 3 words. And I said, well, I know I sent 5, but only 3 got there. I better resend the whole message. Let's try again. And so it's called the CRC checksum, cyclical redundancy check, I think. So they use headers. So they might send, first they'll say, okay, I'm going about to tell you 5 words, and it's going to be starting with vowels or consonants kind of thing, and that's my header. And then you send a message, and then you do a checksum. Okay, how many did you get? And so you know, like, all right, you told me at the beginning you were going to tell me 5 words, but I only heard 4. Oh, something's wrong. So they use headers to kind of know if you're losing data and to order them and lots of other things. So something that's included in the transmissions are checksums, headers, and CRC checks. What is an ARQ transmission system? ARQ stands for auto repeater. Oh, automatic repeater request. It's an error correction method. So an ARQ transmission system is a method of figuring out if you've got errors to retransmit them to so that you get the data that you want at the end of the day. All right. The packet system, it says it's only like 300 baud, so it's really slow, but it can be average of 3,000 bits per second. Automatic repeater request is ARQ. So, all right. So the next one, some of these you just have to know what it is and memorize it. So on 5-13, it says, what does the abbreviation PSK stand for? So that's phase shift keying. So there's 3 ways you can modify a wave: the frequency, FM, the amplitude, AM, and then the phase, PSK, phase shift keying. So those 3 different ways. So PSK is phase shift. Yeah, it does say in the middle there, RTTY was used in the 1930s, so it's been around almost a century now. That's the very earliest data mode. Okay, the next one is APRS. What kind of data can be transmitted by APRS? So APRS stands for Automatic Packet Reporting System. So it uses GPS. So this one doesn't have a GPS chip in, but some of these, well, maybe it does. I think it does actually. It has a GPS chip in it, just like your phone does. Your phone has a GPS chip, and then you tune into, say, a map app, and it will show that you're moving in the map. Well, based on the GPS of where I report I am now, and then 5 seconds later, and then 5 seconds later, I can tell how far I've moved, which tells me my speed. And if you have 4 satellites, you get altitude. 3 satellites, you get position and direction. And so you take your GPS location, you transmit your call sign, and if you do that in an automatic way while you're talking as well, you can get a map that shows where all the different people are. So let's say you got a search party. Hey, a skier was on a resort and there was an avalanche, we got to go find him. And you might send 10 people out with 10 different radios. You turn on APRS and you have a base station. And you're constantly, your radio is picking up your GPS and is transmitting where you're at in your call sign. You say, okay, Bob's over here, Jim's over here, and you might do a search grid. And you just start moving around, and the base station will be like, okay, go search this grid. Next guy, you go search that grid. And so it's a real-time way of tracking the stations that are online using data, and it's called APRS. So you have to have special equipment to do it. I've never done it, but apparently you can do that. What is an application of it? You can also transmit weather information. So for, say, hurricane watches, flash flood, thunderstorms, that sort of thing, they have what are called spotters. So spotters will go out there, train people that are trained, and they'll go listen and look at the weather and then say, oh, hey, look, I see a funnel cloud forming. Hey, there's a funnel cloud forming. And the guy looks at, the weather guy looks at the radar, and he's like, yeah, I think that's true. The guy spotted it, and they'll issue a tornado warning based on the spotter. And the APRS is part of that system that can help report weather and position of where people are. Call them digital repeaters. And there's gateways that interact with a network of that. All right, so, and then on 514, I have an example of like a map. So just think of like 10 different people in a search party with little dots representing each of those people with a radio. All right, and then they have some diagrams here. 5-10 is how you would hook up. This is more digital mode. Let's see, how much time do we have? I'm almost done. a couple more pages. And we're a little bit over an hour, but I'll try to finish this up. Okay, how are the transceiver audio input and output connected in a station configured to operate using FT8? So FT8 is that data mode that we were talking about, and that diagram shows you how it's hooked up. So TNC is called a terminal node. Oh, I forgot where I see connector or something. Controller. Terminal node controller. So down here you see this little TNC. That's a terminal node controller. This little box there. It goes to and from the radio and the computer with data. So that's kind of like your modem for data, converting from ham radio to your computer. So you have this TNC. Let's see, how are they? I guess I'm not sure what the question is asking. I think the question would be like, here's a diagram, show us how it's connected, or tell, I don't know what the question is actually going to say, but it's connected like this diagram. So
I think I saw it's just basically like the audio goes in, the audio goes out, and then you have an electronic keyer.
okay, so audio in, audio out, electronic keyer. That's how it's connected. Okay, for FT8. Thanks. I think that might have been on the previous page. Yeah. Yeah, let's see. It says, yeah, it's WSTJX runs on computer and audio tones for transmit and receive, passed to and from the sound card through a USB interface. And that's using PTT or push to talk to transmit. So sound card mode is FT8, it's using that package we talked about. All right. So I'll skip over that. Now the next one, 515. There's another diagram up there. Internet gateway. Okay. So these are really useful for, say, digital linking of repeaters. So let's say I'm here in Utah and I want to talk to somebody in Virginia. Well, VHF FM only goes about 50 miles at the most, maybe 75 if you're on a mountaintop. And so I'm not going to be able to talk to someone in Virginia. So what they do is you go to the repeater and then you go through data, back out through the internet, and you go from internet to internet, from my internet repeater in Utah to my internet connection in Virginia, and then I go back out to the local area in Virginia. So that allows me to key up something like this that can only go 20, 50 miles and still talk to someone in Virginia because I'm using an internet gateway type of thing. So it's called a gateway. So they have a little section here about gateways. So it's a digital way to connect stations or repeaters. Some of those examples are Echolink or IRLP, Internet Radio Linking Protocol. Echolink, IRLP, those sort of things use gateways to do that. Okay, next one. 516, power supplies. I kind of went over that at the beginning, but just to recap, power supply, it's real basic. You just have a little connection here to plug into your wall outlet, like 220 volts, and then right and left, positive and negative here. Red is positive, black is negative. You hook that up to your radio, and my particular one happens to have a nice little connector to it that I plug into my radio, and so this generates power. And normally they call it 12 volts, so like your car runs on 12 volts, but when you turn on your engine and your alternator's going, it's actually putting out higher volts. It's 13.8. So you want to simulate what your car does, so it'll have the rating and it says 13.8. So it's actually a 13.8 volt power supply, and your voltage is going to drop a little bit when you start transmitting and drawing a lot of power. Like if I were to do 5 watts, it'll draw a little power, it might drop to 13.5 volts. But if I were to draw 100 watts, it might go down to like 12 volts or 12.5. So it allows you to still put out by starting at a higher voltage because you're going to use a lot and it's going to draw down the power. So if you want to take a mobile unit like in your car and you want to be able to pull it out and use it at home, then you want to get something like that power supply. So if you're operating, say, a 50 watt power output, the ratings on these power supplies are going to be the voltage, which are going to be regulated or pretty much fixed. And then there's going to be the amps, so which is kind of like the current amount of, think of it as the water hose analogy. The voltage is kind of like how big around is your pipe. Are you buying a fire hose or are you buying a garden hose? So that's pretty much fixed. But what is variable is your water pressure. So your water pressure is like your amps. So your power supply is rated in amps. How much pressure can it put out? So they have a little formula in here for figuring out how many volts or how many amps you need to use. So the more power, the more amps you're going to need, which is going to cost more for the power supply. The lower amps will cost less. So their formula is take your maximum watts, like 50 watts, and the example is divide by the volts, 13.8, and you get 3.6 amps. Well, then you need to double that. I think it's because you get surges, and that's 7.2 amps. And then you want to round up because you don't want to generate less 7 amps when you really need 7.2. You want to go up to 8. So then you go, okay, I need at least an 8 amp power supply if you're only going up to 50 watts. If you're going higher, then you might want to go higher, like 12 or 20 watts. So if you're 100 watts, you might want to go up to a 12 amp power supply. If you're going more, you might need to go to a 20 amp power supply. So
I did notice that there are some trick answers on this one. Like,
okay.
When you do the calculation, it's on one of the answers. It like comes out to 50 watts. You might be tempted to choose that one, but you need to go. You need to have enough amps that you can go above 50 watts.
Right.
A power supply that delivers just 50 watts won't allow you to transmit on 50 watts
Right.
anymore.
Right. So you take your amps or watts divided by the volts, and then double it, and then you want to round up. You want to give yourself a little wiggle room. So instead of 7.2 amps, you want to go 8 at least. You might even want to go 12. But yeah, so more amps is always better. Oh, which leads me to another thing. Leads me to another thing I want to talk about. It's kind of hard to see in this one, but let's say I have two cables. There's called a gauge. So one of these is a high gauge, which is narrow, and one is a low gauge, which is thick. So these two are thicker than these two. So the thicker one can carry more amps, and the thinner one carries less amps. So the thinner one, this is for a 50 watt radio, and the thicker one is for a 100 watt radio. So if I have a 100 watt radio, I want a thicker, like this is like your fire hose versus your garden hose. 50 watts, garden hose. 100 watts, fire hose. Okay, so you're going to want to make sure you have enough, thick enough gauge to go over the power that you need. Because if you were to try to do 100 watts over the narrow gauge, what's going to happen is you're either going to trip your fuse or you're going to heat up your wire, which can have a risk of a fire. So most mobile units only go up to 50, so like 14 to 16 gauge will be fine, but if you're going up to 100 watts, you want to use like 12 gauge wire. So that's just a little safety trick for you. The next question, what type of circuit controls the amount of voltage from a power supply? It's a regulator circuit. It just regulates how much voltage and tries to maintain constant supply. Next question, I'm going to go to 517. Oh, actually, that was a test question. Why are short heavy gauge wires used for transceivers DC connection? So why do you use these thick wires when you hook it up to a mobile unit? So you don't fry your system. So you don't overheat or cause a fire. You have enough battery power to work. So if you do a mobile unit, the last thing you want to do is plug that into a cigarette lighter, because it might be rated for like 3 amps or 5 amps, but it's probably not going to go up to 8 or 15 amps, and you're just going to trip your circuit. You're going to fry a fuse in your car if you try to hook it up to a cigarette lighter. So generally you want to hook it straight to the battery. I do have a video or two I'll post on our channel and on the link of how to hook up your wires between, it's called the firewall, between your engine and your passenger compartment. How do you get a wire between those two? There's a little firewall place you can go. It's different depending on each car. But generally you take the trunk release or the gas can release. It's usually a physical cable. Sometimes they're electronic, but they're physical most of the time. And you find where that cable goes and you go through that path. And you basically go through the firewall and then hook it straight to your battery. So if you're going straight to your battery is being charged while your engine's running, or even if it's not, it'll still run and it won't fry your wires or create any hazards. So you always want to hook it straight up to the battery. All right, so next thing, we're going to talk about batteries. This one's fun for me because it's pretty easy because I've used batteries all my life, but just kind of review for those of you who already know, or just teaching you if you don't know. What hazard is caused by charging or discharging a battery too quickly? So if you turn on a battery and just use all the power at once, it's going to heat up. So that's the hazard. It's going to heat up. And it can actually, in a lead acid battery, like most car batteries, it can produce explosive flammable gases, which can be a risk of a fire if you do it too quickly. So a lot of batteries, even today, it'll say, say you got a AA battery, it'll say don't put this in a fire because it could actually explode because it has chemicals in it and gases that can make it explode. All right, next one, how can you determine the length of time that equipment can be powered from a battery? So let's say this thing is generating 5 watts and I've got a 5 milliamp hour rated battery. 5,000 milliamp. There's 1 amp and there's 1 milliamp. So 1,000 milliamps is 1 amp. So 5,000 milliwatt battery is 5 amps. If I was, say, transmitting 1 amp, 1 watt for 1 hour, then 5 milliwatt would be for 5 hours. So I could transmit straight on 5 hours if it was 1 amp per hour. So you take the average amps and divide it by the milliamp hours, and that tells you how long you can run on your equipment. All right, and then they've got a list of chemistries on 5-18. They have a little table of all the different types of chemistries. And really all you need to know is what is rechargeable and what's not. Because you don't want to put, the answer isn't alkaline. Alkaline is not rechargeable. It's a one-time use. Like the Energizer Bunny, right? You just use it, it keeps on going, but when it doesn't, you throw it away, okay? Disposed of properly. But you don't want to try to recharge an alkaline battery. It will overheat and can create problems, and it won't do anything either. So there's various types. So what type of battery is not rechargeable? It's alkaline. What type is rechargeable? Everything else, pretty much. The list, the first rechargeable batteries that I was exposed to in the 80s was NiCad, which is nickel cadmium. So NiCad were the first ones, and then they got more advanced, NiMH, nickel metal hydride. Those last a little longer and were better. Now we have LiON, lithium ion batteries. There's also lead acid cell batteries. That's what's in your car. And those are all rechargeable. So it is important to note that you don't want to use a NiCad charger on a lithium ion battery or vice versa, because it's going to generate a different amount of current and different amount of charge, and it can fry your battery or create a hazard. So you don't want to use the wrong type of battery charger on the wrong type of battery. And then they have average rating based on the size of battery, like a AA, a C, a D, and it tells you your voltage and how long it will last. So the bigger the battery, the longer the milliamp hours, the longer it can go. And the smaller the battery, the shorter it can go for the same amount of power. And let's see, I think that's it. So that's it. Thank you for tuning in to my channel. Thank you for coming. And we'll see you next time. And next time, just for the note, is next week is going to be President's Day. And so I'm going to be taking off next week. But the week after that, we'll be resuming same time, 7 o'clock on the Tuesday after next week. So, and that will be covering Chapter 6, Operating with Other Hams. Oh, and by the way, this chapter, there's only 16 questions out of 35 from this one. So that will help you know. Next week, Chapter 6, there's 23 test questions out of Communicating with Other Hams. So this is, Chapter 6 is the chapter with the largest number of tests on the test question, or questions on the test. Thank you for tuning, and see you next time.